Good morning. I am welcoming back you in the matrix algebra through SciLab elective course EG1308. Let me go to the SciLab. Okay. So we in the previous sessions we have used the RRE form of the matrix to find the inverse and all. Now in this session I am going to discuss about the eigenvalues and eigenvectors and how to evaluate that using SciLab. So let me call matrix A what we have done in the previous session, that is 1 2 3 4 5 6 1 2 1, and the matrix B, that is 8 minus 6 2 minus 6 7 4 minus 4 2 minus 4 3. Now I want to perform the eigenvalues and eigenvectors for these matrices, that is A and B. One of the eigenvalues for the B is 0 because you know that determinant of B is 0. So since determinant is of B is 0, you know that at least one eigenvalue is 0. Okay, so how to find out all the eigenvalues of your matrix B? Command is spectrum of B, SPEC B. So here see you are getting that 7.288 d power minus 16 means it is approximately 0. The another eigenvalue is 3.000 means it is approximately 3, and lastly it is given 15 means it is exactly 15. Now if I want to find out the corresponding eigenvectors, then you have to perform this operation but with extra one things here. Let me say x comma y, let me write both capital, is equals to this. Means in bracket x comma y bracket complete is equals to SPEC, that is spectrum, in bracket B. What this will provide you? It will write down this eigenvalues and eigenvectors in this fashion. See what is the fashion. Here these values, see this is approximately 0, this is also approximately 0. It is giving you different, but you know that it is 0. Okay. So this is the 0, this is 3, and this is 15. Means here you are getting the corresponding eigenvalues. Now here you are getting eigenvectors, and here in the column you are getting this vectors, that is 0.3333, 0.666, and 0.666 is the corresponding eigenvector for 0. Okay. So if you write in the other fashion, you divide everything by 0.333, you are getting here this value 1, here 2, 2. So you may come across that 1, 2, 2 is the eigenvalue, sorry, eigenvector for 0. Okay, because you know that via scaling eigenvector does not affect. Okay, similarly here you are having something else, that is 0.666, 0.333, minus 0.666 is the eigenvector corresponding to 3. Okay, so if you will write in proper sense, here you can write here 2 1 minus 2. So 2 1 minus 2 is the eigenvector for 3. Similarly here you are having minus 0.666, 0.666, and 0.333. So that is if you divide everything by 0.333, here you are writing, you can write it as 2 minus 2, 2, and minus 1. So minus 2, 2, and minus 1 is the corresponding eigenvector for eigenvalue 15. Okay, if you want to perform, let's see, let what I have done B, and I want to multiply it with the eigenvector. Let me say eigenvector mine is for the, let me write for 15, I am writing which one? Minus 2, oh sorry, is equals to in bracket minus 2, 2 minus 1. So B star E. Oh, sorry. I have to write E. It's per. So transpose. Okay. So B star E. See what happened. Just everything is multiplied with 15. So you know that this is the eigen vector for 15. Okay, so this is multiplied with 15, so minus 30, this is multiplied with 15, so 30 and minus 15 here. Similarly, you can perform, okay, let's do this similarly for 3. Here you are having, as I have said, either write in this fashion or divide everything by 0.333, so you are having 2, 1, minus 2. So let me say E2 be 2, 1, minus 2, correct? 2, 1, minus 2 transpose. So now go for E star, B star E2. So see, everything is multiplied with 3. 2 times 3 is 6, 1 times 3 is 3, and minus 2 times 3 is minus 6. So you can say that it is the eigenvector for 3. Now for 0, you are having 1, 2, 2. So let me say E3 be 1, 2, 2. Oh, sorry, I have to write dash. So it will give me column vector. Okay, so now I have to perform B star E3 and it is saying 0. Okay, so you can now say that 1 to 2 is the eigenvector corresponding to 0. So this is the way to find out the eigen values and eigenvectors for given matrices. Okay, and of course, here it was possible because everything was in multiple of 0.333, so I could find out the exact in this fashion. But if it is not in some good sense, for example, let me go for B. Instead of B, let me go for A. What happens if I find out the eigenvalues of and eigenvectors of A? Oh, it is in complex numbers. And I cannot find any pattern here. So I cannot write that in that good fashion like this 2, 1, minus 2. Okay, but of course these are eigenvectors and eigenvalues corresponding these. This is the eigenvalue and this is the corresponding eigenvector. That the first column, the second column is for the second and third column is for the third. So I hope you have enjoyed this lesson. Do the practice of this at home. Stay at home. Stay safe. Thank you.